to evaluate, which means we have to come up with a number. However, when we look at this to begin with, so if I just rewrite out A here. First of all, we remember that log solve for exponents. So I think of a little exponent there, and this would be a non-calculator question, and I go, I have a problem. I don't know 9 to what power is 6? Those aren't on the same column as my powers chart. 9 to what power is 72? I know 9 squared is 81, but I do not know what number would be 72. And yet this is a non-calculator question. So a strategy that we're going to use is we're going to use that strategy of combining things as a single logarithm and see what happens. So if I wanted to put this in as a single logarithm, well, I'm subtracting, so I think my log law was subtracting, but my log law with subtracting will only work if I have 1 log minus 1 log, and I have a 3 on the front. So I'll always have to, when combining, put those numbers in front as exponents first. And now I can write this as log 9 of 6 cubed over 72. There's some big mental math here. And when you're doing mental math, there are ways of doing mental math that the mental math is harder, or ways that do mental math that mental math is easier. Especially when you're dividing. When you're dividing, I could multiply out 6 cubed and get 216, and then simplify 216 divided by 72 and figure out what that is. But those are some big numbers. Sometimes it's easier if you break things up into their factors. So 6 cubed, of course, is 6 times 6 times 6, and 72 is 36 times 2, which is 6 times 6 times 2. That is a lot easier than doing 216. First of all, knowing that 6 cubed is 216, that might take a while. And 6 divided by 2, this becomes log 9 of 3. So again, we think of that question mark there. Some of you might be able to see this and say the answer right away. Perfect. If you can see the answer right away, just put it down as the next step. If you can't see the answer, then you might want to say let x equal log 9 of 3. My base is 9, my exponent is x, is equal to 3, and then think of your powers chart. Are 9 and 3 in the same column as our powers chart? Yes. I can change 9 to 3 squared. And then I would have 3 to the 2x on this side, and 3, there would be a 1 there. And if you get your bases the same, and you would get 2x equals 1, and be able to solve for x equals a half. So the question is, how would someone know this is a half right from the beginning? Well, 9 to the half, that's the same as the square root of 9, right? That important rule from grade 10 and 11. So making sure you know how to change fractions to square roots and thinking of square roots and cube roots as part of your exponents is important. So you could say, hey, I know that the square root of 9 is 3, so then that question mark would have to be a half. However, if you don't remember that, it's nice to have this strategy where you can change it back to exponential form, get your bases the same, and solve. I'll scroll back up. will do b on this side. So again, if I think of question marks, I do not know 4 to what exponent is 6, 4 to what exponent is 3, and 4 to what exponent is 12. So I'm going to use the strategy of putting everything together as a single logarithm, and I'll start by moving those exponents in. And once you're adding and subtracting single logarithms, we can combine this all together. First, we notice all the bases are the same, so we can use our log law. Whichever ones are added, which would be the 6 squared and the 12, they all get multiplied in your numerator. And whichever ones are subtracted, which is just the 3 cubed, will be in your denominator. Again, you could do 36 times 12 in your head, and then divide it by 27, or you could break things up. 6 times 6 would be 3 times 2 times 3 times 2, and 12 is 3 times 4. So that all my 3's would simplify. And then the mental math is a lot easier. Now it's just 2 times 2 times 4, which is 16. And this one I think we could figure out. Log 4 is 16. Is asking you, what's the exponent? 4 to what exponent would be 16? That one is 2. So you can circle question number 13.